Number 22 in the practice exam, because of erratic rainfall patterns and low water holding capacities of soils in Florida, supplemental irrigation is required for producing most crops. A research team has developed 5 alternative water management strategies for irrigating cropland in Central Florida. A random sample of 100 agricultural engineers were interviewed and asked which of the strategies he or she believed would yield maximum productivity. A summary of their response is shown in the table. Alright, so this is the table. This is the summary of the response. Notice that this very top tells us the strategies. So they divided each strategy and called it A, strategy B, C, D, and E. And the frequency refers to the number of people, of the 100 agricultural engineers. 17 decided they want strategy A, 27 decided they want strategy B, and so forth. Okay, so this is a question that you need to use goodness of fit. And one of the ways that you can identify that it's a goodness of fit, and I tell this to my students, is if you see one row, in several groups for the columns, then chances are it's a goodness of fit question. But again, when we teach about goodness of fit, one of the things that we say is goodness of fit is frequencies. But you can also think of it as like multiple probabilities, and sometimes we think about probabilities as proportions. And the reason we say that is because each of these 17, 27, 22, these are counts of successes, basically, of people that want strategy A, people that want strategy B. And these counts of successes, this has a total amount of people that we would expect to vote for that strategy. And we would expect 20 because that's the most even way, that's the only even way we can distribute the 100 agricultural engineers. So 20 here, 20 here, 20 here, and all of this adds to 100. So you can think of it that way to recognize that it's a goodness of fit question. But again, I think the easiest way is to just look if there's one row and several groups. So when you set up your null hypothesis for goodness of fit, you say that each of the probabilities are all equal, right? So strategy A, the probability for strategy A is equal to the probability of strategy B, and then our alternative is that they're not all equal, and you want to state this way all the time. Otherwise, you're going to have to put all the different combinations of how it's not all equal. And what I'm saying by that is you can say that P1 is not equal to P2, but equal to P3. So definitely keep your alternative this way. It's the easiest way for you to make your life easier, I guess. It's the easiest. Your alpha level is 0.05. It's not given to us, but we assume that it's 0.05 if it's not given. All right, so to plug this into the calculator to solve for the goodness of fit, instead of putting it into a matrix like you would for a chi-squared, you want to put it into a list. And what we want to put for our first list is the frequency, so the counts that we get for the individuals and what strategy plan they decided to vote for. So 17, 27, 22, 15, 19, and then list 2 is going to be the expected count. And what we did here is we wrote it down for you 20, 20, 20, but what you could do on your own, because obviously in the test you're not going to be given the expected, you're going to have to solve that. What you do normally is you look at the total size n that they give you and divide it by the amount of groups that are in the data table. So 100 divided by 5, so 20, and that's the same for every strategy. You would expect the same counts for every strategy, ideally, right? Nothing differentiating from each strategy or what people prefer. All right, so now that it's in list 1 and list 2, what we do is we go to stat, test, and towards the bottom you have the chi-squared goodness of fit test. And then you want to say that the observed is list 1, which is the frequency, the expected list 2, and the degree of freedom. The degree of freedom for goodness of fit is the amount of groups minus 1. So you have 5 minus 1, so our degree of freedom is 4. And let's calculate. Here we go. Our chi-squared is 4.4. Our p-value is 0.35. 0.355 if we approximate. And if we compare that to an alpha level 0.05, that's greater, so fail to reject. And a conclusion, or the conclusion for this particular question that this person wrote out, is not enough evidence to conclude that there is a difference in the strategies. So that's it.